So far, is what we
Okay,
have.
as a scientist
Yeah.
who is qualified to give us a verdict, what does this result give us? There is a very strange characteristics that the often
Yep.
shows totally ratio than pra.
Because
Yes.
the
But
offering, okay, let me, because the offering was treated with CO2 gas, and then the pra was treated with copper oxide gas. So they
so
are two
copper
separate.
oxide shows a better performance than CO2.
So yeah, sure. Sure.
But the CO2 costs nothing to produce where copper oxide does.
Yeah.
Can we speak with Dr. Nash, please, Benjamin? Um,
That
Dr. Nash, um,
Yes, Mr. Keshe.
yeah. Um, what is, we see a lot of reduction. Okay.
Yeah.
We see a lot of improvement in reduction of the all sorts of things. But
Yes.
are these all beneficial to be withdrawn? Or can be selective and keep some? Water without
Yes.
nourishment is no good, but part of these things are nourishments for animals or whatever. Can we become selective? I mean, is this water okay for consumption most probably, but void of everything
Yes.
more or less?
Yeah. We realize that with the copper oxide treatment, it's more effective than the carbon dioxide. And
Mhm.
it's even when you look at the guideline values for drinking water, you realize that some of the parameters it's even lower than the guideline values, telling us that the treatment using copper oxide has been very effective. These guideline values came about when we haven't come across the treatment with copper oxide and carbon dioxide. I believe the guideline values are from what Ben earlier shown, the traditional way of water company here going through the processes of treating water. So based on that filtration or the treatment system, that's why they came out with these drinking values. And now that we have advanced forward with copper oxide treatment coming in, we realize that we can even go lower than the guideline values, which has been set for some years now. So
Would it
if this
be,
is,
would your government consider to implement this?
yes, and I'm sure they would, but they will call for further tests on a wider scale, and that will go through the processes and the government will surely, because this is even cheaper compared to what we are spending treating our water for public consumption at the moment. So it's a big breakthrough if all hands on deck, relevant people are brought on board and we sure the government will give an ear to it.
Is it possible to get a couple of error on the page to be corrected?
Yeah,
And
sure.
if we could have a written report, a scientific report of the evaluation of this result that
Yeah.
we can share with number of governments,
Okay.
because this allows a huge difference in, because especially when I look at
Yeah.
the salinity with copper oxide, this allows the seawaters for
Yeah.
countries like
Can be
here
used.
in Dubai to be literally cleaned out. You can drink it, you can put it through and drink it. How long did it take? How long did you leave the two to stay? A day?
3 days.
3 days. Was
Three
it
days.
effective immediately or after 3 days you got to this point? Would it be any different if it would have been just one day?
Mm,
after putting it down, we started seeing changes after 1 hour. The water was clear. So Dr. Nana was even asking me, Why is the other one, that's the copper oxide, going, clearer than, but I have already tested it in my room and then have found out that the copper oxide, gets clearer faster than the CO2. So I just
Okay,
told her,
Benjamin, what is
yeah.
important, we need to see now, we have a base data
Mm-hmm,
on each river.
mm-hmm,
We have to see if the material which is collected must be in the what do you call it, in the residual which you are testing. We
yeah,
should
the sediment.
find the correlation between the two. It's called correlates. Otherwise, it won't be. We will see where it's gone to.
Mm-hmm,
What will be interesting is, can you, once they've done the test, can
yeah.
you try to see if you can wash the copper oxide or the CO2 out of the residual, that we can reuse it?
Okay.
You understand?
Yes, sir.
So does not matter what is as a residual. There are processes they can take the gold out, whatever. You haven't tested a lot of other things here. But would it be possible to wash the CO2, because we do the washing, Arman is good at it, that we can recycle the material. We don't need to use this to keep on producing it. You understand? Hello, Benjamin. Have we lost him?
Yeah, we might have lost him.
We'll see when he comes back, bring him back on, because he's got to explain to us the other part. What we see here is more or less in line we've seen with a couple of other reports. But now with this report, um, we try to pass this on immediately to certain governments. We know they are working to clean the system up, the process. Um, it is important that we make a proper report of this, and in time um understand it more. I've seen these kind of work past 10 or 15 years. We were fully aware. It's the first time we receive a governmental report. And we'll start seeing these kind of reports across the world. A lot of governments, companies, organizations are doing it. Uh, I'm sure if we can get Benjamin in the background, we will take this with us to China. China has a lot of rivers which needs to be cleaned up. And this has a very little cost of drinking water changes. At this moment of time, I was in a seminar last week, last Monday, not this Monday, the Monday before, official seminar by the United Arab Emirates regarding the water. The amount of water which is imported in United Arab Emirates is huge. Every drop of water is brought in because desalination units, especially like companies which are very big in it, like Samsung, it costs a fortune to do it. This is an easy way out. It allows us to drink water from everything we like. In the rivers, in time of disaster, people like a lot of you who carry copper oxide, now you can use it. But at the same time, if we add to the information that we learn for the future, if you test, we tested these with minerals, but if you do a germ test, microbe test, from the data we have, copper oxide comes totally clean. CO2 creates life. So in cleaning up, if you are taking the residual out, is good. But if you're going for a totally disinfected water that you can literally drink it, doesn't matter what kind of parasite was in it or microbes, you'll find out the copper oxide comes on the top. So we've seen the process, we understand the process, but copper oxide has shown in a number of trials to be a disinfectant. So in having this data, I think we will speak with Benjamin in the time. Is Benjamin back?
Not yet.
I will discuss this with them in the background. You will see that copper oxide has a huge disinfection. It disinfects the water, kills all the germs. It doesn't kill, it literally takes them out into the sediment. They still survive. In the sediment, they do exist. In the above, they don't. And um, I don't recommend the CO2 water drinking, but the copper oxide, when you let it settle, has the property to be.
Okay, got that.
Hello.
Go ahead, Mr. Keshe. Sorry, we had somebody drop out there, which
Ah,
caused our mics to
okay.
open. So you go ahead
No
now. Thank
problem.
you.
No problem. So we know this. We hopefully when we are in China, because the water contamination is huge in China, we know this as the number of lakes in what used to be USSR, the Russian, like in Kazakhstan. I'm aware of the huge lakes which have huge contaminations. This technology, this copper oxide, can be used in the condition of radioactive contamination. If you come, we expect a huge disaster in US in the coming time. Not US, but the continent of America and the whole south
Sorry,
and
Mr.
north.
Kesh, we are back.
Okay, okay, thanks, you're back. Just wait 1 second, I'll explain something. If we expect with these disasters like what happened in Fukushima, a huge amount of radioactive contamination of the water, copper oxide is literally your only guarantee to decontaminate from radioactive material. This is what we gave to TEPCO. TEPCO was shipped huge amount of this copper oxide in different form as what was it called? Talcum powder lotion. We have the shipping documents for it. TEPCO didn't want it to be called CO2. It's gone as talcum powder lotion. We have all the shipping documents. And now that the gentleman who was part of the TEPCO to decontaminate is the director of the Keshe Foundation in Japan. We met him last week. We're seeing the machine last Tuesday. Now we are in that process. So if you come across radioactive condition where we expect the number of radioactive reactors to go off, what we call the power stations, in a case of a disaster, copper oxide is the only solution which gives you sediment-free, germ-free, and radioactive-free. So bear this in mind. What we need to do is, we can do it. It's the beautiful position which Benjamin is in. Benjamin, you're back online. Is Dr. Nash with you? Hello, Benjamin.
Yes, sir.
Yes, you are with Dr. Nash.
Um,
Listen, what we
uh,
want you to do, you have proven that this water is cleaned out of the sediments, yeah? What I want you to ask your team in conjunction with the Atomic Energy Authority of Ghana, because you have the access facilities to it, to do 2 more further tests on the water from the rivers. One
yeah,
is test the water for germs and bacteria. Okay?
biology. Okay.
Hello, can you hear me?
Yes, sir. Yes, sir. We are writing.
Okay. We need to test, okay, now we know the sediment. Forget about CO2. Or you want you carry CO2, carry CO2 too. But we want a test on both river, on one river. Take any of the two. Now we know the result, we go for the best, which is the copper oxide. Leave the CO2 out. When do another test and give us the result in respect to bacteria and germs or whatever is in the water before and after. Okay? In the
Control.
video you showed us last week,
Yeah.
the week before, you showed us people washing the animals, the blood of animals in the rivers and everything. So these
Yeah.
rivers are fully contaminated. Yeah?
E. coli.
E. coli. So I want you to ask the authorities within the institute to what do you call it, do a bacteria test, a full test, like this report for sediment, if you can have a bacteria test and anything
Okay.
else which is there. The second thing, because you are part of the Atomic Energy Authority of Ghana, you're within the institute, ask them to do the same, which is, with you have radioactive material with you, if you can contaminate the water as it is with radioactive material, and then add the CO2 into it and report to us back on the cleaning of the water from radioactive material. This is very important.
Okay.
These are we need. If it can be done very rapidly by next week, because I know you're very slow, it's what do you call it, very difficult to get you moving fast. But even the waters you have now, you still have the two waters after cleanup
Yeah.
and the normal. Test the same waters again for bacteria and germs, and do a simple test of adding radioactive material to the river and its copper oxide, and we would like to see the report in
Okay.
the residual or in the water. The result will come 100% in the direction of the cleanup of the radioactive material. Yeah?
Yes, sir.
And we know this because TEPCO has confirmed it. We know this because we shipped enough material into TEPCO. So this is important. Maybe for the first time Africa can help America in the case of disaster, that the people in America know how to help themselves if any nuclear material is released in the environment due to whatever accident. Not a disaster, we most probably sooner or later, we already know there's a huge amount of radioactive material in the coast of Italy. The African nation, with the small budget you have, you can prove to the rest of the world how they can help themselves. As I told you, Africa will become the flag bearer of the new technology. Yeah?
Yes, sir.
So if you can do it through the Iranian government with support of the Ghana, because I know there's a close collaboration between Iran and Ghana, we will release the technical data into IAEA as part of the collaboration with the Keshe Foundation, Iranian Atomic Energy Authorities, and Ghanaian Atomic Energy. We collaborate as three nations, three organizations, to become a standard for the new standard for decontamination of radioactive situation. We know the answer because we know it from the Fukushima. Certain radioactive material, copper oxide, is effective. If you see any residual, you add CO2 to it for another level. And if you have beta from certain materials, you use the water which you showed it had a mercury in it. That mercury will convert to gold. Becomes a national asset. I'll guide you all the way through it. This is what's happening in Fukushima in Japan. And what you set up, we will show. When I'm in China, we do these tests very rigorously with the Chinese military and Chinese government for cleanup. But I know from 25 years ago, when I used to work in Russia, in Kazakhstan, we had this problem with a lot of lakes which are heavily radioactive or mercury contaminated. This allows a new cycle. With a little amount of expenses, we can clean up most of the problems. So please ask your collaborators in IEA, in what called Ghana Agency, Nuclear Agency, Atomic Energy Authorities, to first of all test these waters for microbes. I'm sure CO2 will give you clearance because we've done this with the South Sierra Leone University. We already have a data from South Sierra Leone University, which they did the data on Ebola when we had the crisis. And from the new atomic side, you can ask your colleagues, because you're in the Atomic Energy Authority, to do a quick test. It takes you 5 minutes literally. You add CO2, you let it settle in 1 hour, and take the waters, the one which is not treated with the CO2 and the one, and you just measure. You got Gaga meters and everything there. You can do the Gaga counters very quickly. Could we have this report within next week?
Nash, sir, uh, I happen to give him a lot of stuff, but they cannot maybe cope with my rate of what do you call it, sample. So he's
We
here
need
to answer for himself.
Dr. Nash.
Yeah, Mr. Kesh,
Yeah,
with the
Dr. Nash.
microbiological, the
Pardon?
microbiology, with the microbiological analysis that assignment you've given us. Yeah, that will be done at another lab, but within the same Ghana Atomic Energy. So we're now going to make arrangements with them and then get the samples for them. So hopefully, I think a week will be too short for us.
No problem. 2 weeks.
2
Humanity has
weeks,
been
correct.
contaminating for hundreds of years.
Yeah,
2 weeks is nothing.
2 weeks. Yeah,
Yeah.
that'll be
But at
fine with
least
us.
if you have any preference. But I know as a nuclear physicist, it should not take you more than 10 minutes to give us a result on the nuclear contaminated.
Hmm. Yeah.
You have
Okay. So two
plenty
weeks.
of
2 weeks will
cobalt.
be okay.
You have plenty of cobalt residual from your disinfected units, which I know you have for radiation system use. I know a lot about your organization. Don't worry. So
Great. Thanks so
if you
much.
could ask, listen, we are nuclear physicists, and if you governments have access to these kind of technologies, we collaborate with different governments. We know what you carry. We're trying to support you with the cobalt for the what they call it, decontamination radiation of the hospital units. I know what you carry in that place. I've seen a full, what do you call it, inside report. That's why we are there to support. So
Okay.
you have some old materials, cobalt and the others which are there. If you can contaminate it, or the water, contaminated water, just add it as a contaminated water. Use a CO2 and use the copper oxide. CO2 will not show. CO2 will show maybe partially for alpha. Beta, you need to use mercury, which comes from the water. If you have cleared the water with sediment, I think you won't see such a good result. But if you, in your test in sediments, you find mercury in your sediments, then don't touch. Take them to put the sediments back in the water, add your radioactive material, and add the CO2, and then measure the sediments. Now you should see a lot of gold. You recuperate all the gold, plus you convert the mercury to gold. So this becomes national asset. You understand?
Yes, please. Yes.
So
Yeah.
this is a huge, any mercury, if any of this residual in the two rivers you see mercury, mercury is your national asset that converts to gold. If you take the residue of the nuclear materials which you have and add copper oxide or CO2 into it as a mixture, you will see gold will rain down. You will see it. This is how we supported, what do you call it, TEPCO.
The code.
Yeah, TEPCO with the Fukushima disaster, they are collecting gold from their tanks.
Mm-hmm.
50
Right.
kilos per tank is on average.
I see.
You understand?
That's great.
So
Yes, I do.
because these rivers are getting exploited for gold and they're using the mercury in it, it's very easy. If you have the radioactive material in conjunction with the gold, CO2 or copper oxide, you might need CH3 to create a chain reaction, which what we send to TEPCO as part of the conversion of tritium. You should be able to see gold dripping at the bottom. This is the only solid because you will see the shiny bit. Yeah?
Yeah.
So it becomes a
Wonderful.
national asset. You can literally sell the gold for your government and subsidize all your researchers.
That's great.
Yeah.
That's good.
We
So two
brought you
weeks will be
gold.
fine.
We brought you gold in the form of Benjamin. Now you can produce gold to sub. That's why I said to the CIA when they brought us into you. when I told the American government when we were introduced to you through the organization of CIA, when we were sent in to collaborate with you, we said when we come in, we make sure Ghana Space Institute and Ghana Nuclear would not look outside for any financing. Because I was aware, I studied the topology, I studied the structure of what is in Ghana and how people operate, and I was aware of this, but we have to wait till the data is there. Now the data is there, we can be open. And I thank the people within the structure of the CIA who brought us to you, because this allows us a lot of work to be done. And it's a great collaboration. And I thank the head of Ghanaian Atomic Energy and the new deputy which you received. We openly collaborate with you in every aspect. Thank you very much, Dr. Nash.
Mr. Keshe, Dr. Nana just walked in, but she's picking a call, and one of the managers for the Biological Institute is also here, Doctor, in the person of Dr. Gordon Amenope, who
Can we have him
yesterday
on the
took me.
line?
Okay, Dr. Amenope, yeah.
Hello, Keshe.
Hello, yes. Good afternoon, doctor. We just we received a report, beautiful report from your institutes, from your organization, Atomic Energy. What it'll be interested, we've
Yes.
seen the sediments. What we requested now, is it possible to have a biological report? The decontamination and pre-contamination of the water, microbes and everything else. That not only we reduce the sediments and the clarity, but has the process, the waters you have left, is decontaminated from any infection, Ebola, E. coli, whatever. Is it possible if you could have such a report from you, please?
All right, and Dr. Keshe, my unit actually deals with plants, animals, and so forth. And we will not be responsible for
But
decontamination.
you have friends within the organization, I presume.
Yes,
Okay,
but
good.
I wanted to talk about different issues.
Okay, please go ahead.
Good. My unit is Nuclear Agriculture Research Institute,
Yes.
and we normally change the genes, genetical makeup, the genes and chromosomes of crops using peaceful nuclear techniques. Right, and the current problems we are having now are related to climate. The rainfall figures are not encouraging. So we want to come out with plants that will have genes that can convert little water into food. In other words, drought-resistant plants.
Can I ask
And
you a question? Can I ask you a
yes,
question, doctor?
yes,
We
please.
know in Africa, I worked in Africa for a long time and I've been in the interior. We know that African ladies carry sometimes 40 different kind of seeds for different climates. They forecast
Yeah.
how the weather is going to be, and that year they use a given seed.
Yes.
Is there a seed in Ghana or in part of your structure without genetically getting modified, which had the property that it can live in a drier condition? There must have been.
Yes.
Must be local
Yes.
seed.
Yes, we have some seeds which can actually do well. Example, lima beans can thrive very well under drought conditions. We have other crops species that actually thrive well under drought conditions, like cassava, special breed cassava are also there. Although they are not seed, but they are vegetatively propagated.
So it is in the genes structure of the seeds, or the, what you call, the fibers, to
Yes.
be able in their memory chain that somewhere down the line they could stand the droughts in Africa. That's why they survived. That's why we got them now, because genetically
Exactly.
it's Isn't. Okay, what you can do, I suggest you test. This goes back in the test we showed a couple of 2 or 3 weeks ago from the research from our group in US and in Philippines. If you put your seeds, you saw the copper oxide, which is brought the sediment down from the water. Put the same
Yes.
copper oxide in a container and add water to it.
Yes.
Take the water or put the copper oxide in a container and put another container inside it with water and put your seeds in it for about 10 minutes, no more than 10-15 minutes. And take the seed out and plant it. These seeds will take up to 80% less moisture to grow, which means any drought condition can be met. These seeds will
Alright.
grow much faster for a shorter season. We know this. I did this test over 9 years ago, 8 years ago. So
Mm.
instead of going genetically modifying, trying to stand drought and pest, if you go on the Keshe Foundation, the work 2 weeks ago, 3 weeks ago is on the net. It's on the agricultural green, what do you call it, blueprint. Just try. Benjamin is with you. Don't do anything else. Just put your
Alright.
seeds in the same CO2 copper oxide or in the same CO2 which you use to create the sediments to clean up the water. Put this CO2 or copper oxide in the bucket and put a bucket inside it and put your seeds and water in there. Leave that bucket for 10 minutes, 15 minutes, an hour, whatever you choose, because the more you leave it, the more you strip the outer energy of the gene and you go back to original seeds thousands of years ago. We know this from experience in Belgium. So
Okay.
take your seed, put it in a bucket, put some water in it, and put that bucket in a bucket which contains CO2, and then leave it for 10 or 15 minutes. Just stir it and cultivate.
Alright.
Okay, can we go to United States to Dr. Ogaba in US? Who?
I'm online. I'm online.
Okay, can you enlighten us there, because you're going to be part of the Keshe Foundation in Africa, and you've done these tests. Can you explain to our colleagues in Ghana what you did and what the result was, that they know they have a guideline?
Yes, please. I
Go
planted
ahead.
potatoes treated with water as control and treated with CO2 gas water. And the ones that I treated with CO2 gas water matured 2 weeks earlier. And the weight per potato was not different from control. Maturity was faster for potatoes treated with gas water, CO2 gas water, and all I did was submerge the the potatoes in CO2 gas water for 5 hours before planting. And my presentation, I can see it online. I guess Rick has it online.
Yes. What we've seen with Dr. Mkopa is that it supports the research in the past that if you can even nano-coat copper pipes before you, outside of the pipe that pass the water through, you will find out that the harvest is much better. You'll get a better harvest too. So, and you need less water. Our research in US from the Keshe Foundation Innovation shows you don't need to water 7 days a week. You can water twice a week, for example. So by the use of CO2, water of the CO2, you never change the amount. You keep the bucket of the CO2. You just put a bucket of water and you just whatever you need to put. You want to put potatoes, you put it in there and leave it for a while. You want to do seeds, you do it. You do it for 1 hour. Potato is different because it's more dense. With seeds, we've seen 10 to 20 minutes is more than enough, and you plant the seeds. And then you can even water it with the water of the CO2, the same water which you put the seed in. You can keep it in the bucket and keep on watering the plant with it. You'll find out you need less, much less water, which instead of let's say 100 liter, you use something like 20 liter of water. The harvest we have seen in research done, very controlled research in Belgium, your harvest goes up by 3 to 5 times in foliage, which is good for the animals. And you will see that the cultivation time reduces by up to 30%. So you can cultivate in the time of drought in a shorter time, get the harvest, and you can do a lot with it.
Thank you very much.
Thank you very much, Doctor. Dr. Kwagawa is going to run the Keshe Foundation in Kenya. And we bring all the Keshe Foundations in Africa together to collaborate. Is there anything else from Ghana you would like us to help you with, or because we can collaborate together?
All right. Can we get the Kenyan contact so that we can communicate with him?
If you want, I send him with pleasure to Ghana. He
All
can
right.
stay with you for a while. He's a doctor in agriculture, he's economy. He can help you and then transfer the knowledge. I know you have a close connection with the atomic energy in Kenya, that he can transfer the whole thing to Kenya. Some of your colleagues in Kenya already use the energy units which was built by Benjamin, which they took to Kenya. I organized that. He will come to you, and then from there to Ghana. Is that good with you, Dr. Oba?
That's perfect. I would also very much like to go there and talk to see Benjamin and the rest of his group. Thank you.
Thank you very much. And we organize this within the next 2 weeks before we go to China. Thank you very much. Thank you indeed.
And I want to make another submission from Ghana.
Go ahead, please.
All right. Are you please in favor of GM modifying crops?
No.
All right. In my job line, I don't do gene transfer or genetic engineering, but what I am trained to do is to use nuclear energy to modify the genetical composition of crops for drought tolerance, disease resistance, high yield, high beta carotene levels, to prevent blindness of children. Is it also acceptable to you using nuclear energy, pure nuclear energy, not gene slicing?
Okay. As you know, I'm a nuclear physicist.
Right.
And so I have got a fairly good experience in this respect. In the nuclear industry, we use radiation, which is a one-way track. We only give the magnetical. When you use the CO2 the way we just discussed, you will find out you get what you're looking for because you use a plasma condition, which means you give and take, and it brings a new dimension into the world of seed genes or genetic. At the moment you bombard the seed to change it. In fact, if you use the CO2 or if you don't get the result with the water of the CO2, use the water of copper oxide for a more effective pressure. In a way, is not a radiation pressure, is a magnetic gravitational pressure. So in a way, the seed will modify to what it needs to do. You understand? So,
All right.
and it's the way the universe works. In nuclear industry, we force energy in. With the new plasma technology, we allow the seed to find its own balance. And it works more effective. You have no radiation hazard. You don't need to decontaminate anything. But the only thing is, if you don't get the result you want with the CO2, go one level higher, go to copper oxide. And usually with the seeds, the copper oxide is the maximum you need to do. So if you ask Benjamin, if you have the seeds do the radiation process and do the same in parallel with CO2 and copper oxide, or if you want to increase the energy, add a CH3 to it, or you can mix these, and you find out with less than no cost, you can do exactly what you need for. But in a way, if you look at it in nuclear industry, radiation is adding energy into.
Okay.
Correct?
Yes.
This way, you add a plasmatic energy which is balanced and acceptable to the seed. So
Yeah.
you get the same result, a balanced seed, and exactly how you wanted it to work with zero cost.
Mm. All right. So I can understand you that your method, CO2 plus CH3 method, is to reverse the plant to original state that God actually made it in the days of old.
Yes.
Is that correct?
Yes. We've seen these results up to now.
All right. What of if I want to increase beta carotene level 100-fold? If I want
Play
to
with a
increase...
mixture. Play with a mixture of 3 or 4 ganses.
All right. All right. All right.
Till you get the mixture you like, with let's say 10% of this, 20% of the other. You see
Yeah.
where you are giving energy or where you want to take energy. And the copper oxide has the property of giving, taking energy in certain levels. But if you add it with zinc oxide GaNs, which Benjamin can make very easily, you find out it allows the balance within the seed structure. We know this from research in a couple of cases. So Benjamin has to give you a separate, let's say 4 or 5 different ganses, which cost nothing. You've seen it in your center. And then you play with different mixture till you get it right, and the seed will respond, because it's not the radiation. The problem with the genetic modification now is we radiate to dislocate and put it where we want it. This way is a gravitational magnetical. It goes to where you want it, but it's in balance with it. So it's not genetically modified. It accepts a condition. It processes itself to what you want it to do without any radiation at no cost.
Thank you so much, Keshe.
Thank you very much. I've done certain amount of work as a nuclear physicist in this part, in this section of the seeds. I started it in 2008, 7, 8. And I have seen the crops
Okay.
which usually die, they last 4 months more than their usual. And you can regenerate, you can keep on
All
cutting
right.
the harvest and it comes back.
All right.
Thank you very much.
Yes,
Thanks for your
Dr. Keshe, I would like to hand over the mic to Nana.
Thank you very much
Dr.
indeed.
Nana is here with me.
Thank you very much indeed, doctor.
Oh, thank you so much.
I will explain everything to Benjamin in how to make the materials ready for you that you just test. Thank you.
Good day, Mr. Keshe. This is Nana.
Hi, good day, Dr. Nagana. How are you, Dr. Nana?
I'm fine, thank you.
Are you happy with the results?
Sure. We're making a lot of progress and I'm happy with it. So we've been discussing it at the authority level from time to time, and on the MOU, I think it's close to final. but the lawyer wanted to be clear on some things. Especially she wants to know how Keshe Foundation will be infused into the Ghana Atomic Energy Commission system. So should it be a department under the Ghana Space Science and Technology Institute, or it should be a joint company?
Uh,
So
we prefer to keep our independence to be a joint company, but embedded in Ghana Spaceship Institute or Energy Abbas, which is the Atomic Energy Authority.
okay. So we'll
Because
make
I
it.
know if the rule changes in the country and the leadership or the parliament passes a new law, we lose the control. But this way we stay independent, that we can operate and serve the nation.
Okay. So we can make it clear in the MOU then. So I'll
Yes,
put some
please.
things together and share it with you again.
Thank you very much indeed for your time.
Right.
Dr.
Sure.
Nana,
Thank you.
how
Yes.
how can we proceed with these results from what we've seen from the Atomic Energy Authorities now?
Yeah. We need to
Can we
we need to
commercialize it rapidly, or can it be used to be commercialized?
Yeah, we need to go over all the tests again, all the experiments again through the
Mm-hmm.
scientific processes, do the
Mm-hmm.
tests again and invite other institutions which are doing similar work to be
Mm-hmm.
witnesses to those tests. And then we can go public. Once we go
We are
public,
already
then
public. You're listened to by 100 million people. If this is not public,
no,
I
I
don't know
mean,
what
we
is
need.
public.
Okay, I mean to get it accepted in the Ghanaian community,
Yeah.
we need to talk to, we have Water Research Institute or Commission
Yeah.
Institute, yeah, who is the authority for water issues or water resources in Ghana. So
Mm-hmm.
we need to have all our documents right and then talk to them. They can give us the authority to probably go ahead with water treatment and other issues about water in Ghana.
I think your biggest problem is your secretary to get the figures in the right column. Otherwise, everything else is easy.
Yeah.
The,
Okay. So
Thank you very much indeed. Thanks for your long-standing collaboration and cooperation with us.
thank you, Mr. Gill.
Thank you indeed for your time. Thank you indeed.
Thank you.
Benjamin,
Yes, sir.
yeah, please produce as much as you can the gases of CO2, copper oxide, CH3, and what do you call it, zinc oxide,
Yeah.
and provide these in a given quantity to the doctor that they can use it for their seed. Make sure there is no salt content, because if you have a salt content, the salt will transfer is plasmatic condition to the seed,
Seed.
and then that can cause you sometimes is to benefit. It allows the salt in the seed to extract moisture from the environment, so it becomes a sink for watering the plant itself. And in some plants, this works the other way around. So try to give them the ganses with salt water, don't wash it, and try to give them gans with the washed gans. You understand?
Yes, sir.
Yeah. So what this will do, the plant is looking for a moisture, and the moisture comes through the salt content within the DNA of the gene of the seed. So if you add in some seeds the salt water to be there, because now salt behaves as a gas state of the salt, not as a salt as matter state, will bring the gene into a state of being like a thirsty, and instead of drought killing it from outside, it calls for the water, the moisture to come to it, and it creates its own water moisture. In some countries, we've seen that effect. In some countries, due to the climate, it doesn't seem to be responding. So allow them to test both with the salt and without the salt in all four of them, please.
Yes, sir.
Thank you very much.
Mr. Keshe, I'm already collaborating with him in other, what do you call it, crop matters. Yes, yes, I think last 3 days, huh? Last 3 days, he took me around Ikrabo lands where I can do a lot of experiments concerning agriculture. So it's in line. So I'm working with him already, and
Yeah,
he
what you
has.
got to learn, Benjamin, get yourself a meter, 2 meter of copper pipe,
Mm-hmm.
nano coat it from outside, cover it with a plastic tube, and let the water go through it very slowly. And
Okay.
feed your plants all the time with this pipe. You understand?
Yes, sir.
So what you do as you water, you feed. You add energy to your water, plasmatic, and the plants will grow totally different. And when you do it, try to spread the watering not to every day. If you plant one side every day, plant this waters, measure the amount of water that you know how much you're watering, and that's what it is. You got to understand at the moment, water shortage, water distribution, agriculture has become a big game. For example, China is short of water. What they have done, they have leased properties in Africa and in Argentina. What they're buying is a water rain, they call it water rain purchase for agriculture. The water rain in those districts are used to make soya to be shipped back to China. So you got to take a measurement of how much water you're feeding to the plants, not just feeding it and looking at the plant, how it's growing or if it's growing faster. Measure if you give 100 liter there, if you're giving 20 liter. This is the real test of the technology. You understand?
Yes, sir.
And connect you, if you're watering with a hose pipe, measure the water. If you're measuring with the hose, with the tanks, add a copper pipe, not coated from outside, not inside.
Outside.
With the,
Oh,
put a
okay.
plastic on it that it doesn't get destroyed, and water it and measure it, you will see the difference. Very quickly you see 70-80% reduction in the water consumption, and you will see up to 30%, up to 4 times, 5 times more what we call foliage. So when you work with them, work correctly, and then you do the seeds with the salt, without the salt, and then you see how they want.
Okay.
There is no need
The
to
la-
use of radiation anymore in any food and agriculture. Now we have this technology.
okay. I was about to, before I completed with the water thing, I showed a picture of what we have actually done, and it
Carry
shows
on. Would you
the,
like to share with us the screen?
okay. Sure.
Is there a problem?
Yeah, there's a problem, but we are on
It's
the,
coming up. You're coming up. There we are.
okay.
You have the last picture we see now. Yeah,
That's
please.
the last picture we see. This is what we are about to do. So you see the ends, there's a connection point at where the tube bends. That is where we are going to put the nano coated tube outside so that it will water the plant. And these beds have very, seeds which have been nano treated in different configurations. So I have all the permutations also drawn, and once it's ready, my IT guy is a bit indisposed, so he's not here, but I have seen that he has done a lot of work so far. There are some few corrections I want him to do on them, and then we can share it so that those who have, what do you call it, expert knowledge in this field can also add their knowledge to it. So that is what,
Benjamin, when
yes
do
sir.
you start this process?
Uh, we It's all I just went to see Dr. Amenope to see the land, but already I have started the process already somewhere, but I'm not getting the full cooperation from that end. So I have even abandoned that project. But this one, I will have people who will be able to man it for me, because here, if you give something to
You know
somebody,
what we can do, Benjamin?
yes, sir,
Benjamin, the
yes, sir,
biggest agricultural university in Africa, the most famous one, has
hmm,
always has been South Sierra Leone University.
okay,
It was a jewel in the crown of the agricultural universities in Africa till the problem started a few years ago. We always promised, what do you call it, the chancellor of the university, he wants to bring back the university back to what it was. Uh, we have still the situation with Ebola there, but maybe between you and Dr. Waba, which is coming to you from
Godwin,
United States, we can join you up
okay,
with
Dr.
the
Mutre,
professors in South Sri Lanka University because they need this for food. Would
okay,
it be possible that we can put you together in that way? Because one of the seeds I think you got to try, extra cassava, is rice.
rice, okay,
Rice.
we are in position, we are in position,
Try to see how you can do, because what Americans have done over past 20 decades, they imported American rice so cheap that it was not worth for the farmers locally to produce it. So now they are forced to buy, and the new seeds are agriculturally modified that it doesn't give them what they need for the next harvest. If you can show how you can reverse what I call the genetic modification of the seeds, which you can do, and share it with the scientists in Kenya and in Sierra Leone, I think we achieve a major production in rice. And we can even go back to the original rice, which a lot of we can grow in the dry season.
okay,
This is
but Samanafe
fantastic. What
is not
you
in
have put in front
existence.
of me in that picture, what I've been trying to do for nearly 2 years. You dangled the bait, so now I bet. Now you better do. And I'll bring as part of the collaboration the director of the Central Bank of ex-director of Central Bank of Sierra Leone to be collaborating with you with this. And he's ex-director of the World Bank, and he's very good in these things. He is from Africa, and he understands the problems. And we can raise a lot of funds in Africa for this project to stop the processed genes.
Okay. So
Yes.
in line with this, uh, I have told Anash that I'm bringing some samples to his lab. So we'll do after and before soil sample analysis, and the water that will be used to water this crop will be tested periodically to find what is in the intake point and the, what do you call it, the outtake point and the intake point. So we'll do that and see what is inside before it gets past the nano exit, so that we'll also know.
Uh, can I ask our colleague in US, how fast can you get to Ghana? Is your suitcase ready?
Oh, I'm ready, but I thought I would go to Kenya first and then go to Ghana. That may be easier.
Either way, let me know when you travel, and we finance the rest of it the minute you tell me you're moving.
Okay, thank you.
Please, because I think with your experience you've done, you can bring correct test trials in Ghana and transfer the knowledge back to Kenya.
Definitely, I look forward to doing that. Thank you.
Anytime you fly, we'll support you. It's all in your hand from now on.
Thank you.
Thank you very much indeed.
Thank you, Mr. Kesh.
Thank you very much for a beautiful job, Benjamin. Try to support the measurement of the what do you call it, microbes and bacteria in the water if you can do that. I could carry it with me
Okay, we will
before I
do
go
that.
to China. And the contamination of radioactive material is a gift from Africa to Americans if this disaster happens and we get radiation spillage, because the number of nuclear reactors sits on the right boundaries of the plates. It'll be fantastic. You're sitting right inside the Atomic Energy Authority, and we can ask our colleagues in Iran for a direct collaboration and transfer of technology in different ways.
Thank you.
Thank you very much indeed. Thanks, Dr. Nana, Dr. and all your support in the Institute. All the best. We'll see you next Thursday.